So in number 11, it asks us to find the x and y coordinates of the center of gravity of a 4-foot by 8-foot uniform sheet of plywood with the upper right quadrant removed as shown. How do we solve this? Well, first thing I'm going to do is you can already see here, sorry, so I backed up a little bit. I'm going to break this into two rectangular pieces, actually a square and a rectangle. The red piece there and the rectangle there, and you could do it other ways as well, but I'm just going to do it this way. Why? Well, we can think about the center of mass of that red rectangle as being right in its middle. And those coordinates would be, of course, 2, 2, using that origin, 2 over, 2 up. And we don't know the mass, but we assume it's uniform, so the mass should be proportional to the area. In this case, what's the area of that piece? Well, it's 4 by 4. It's 16 square feet. Likewise, we can talk about the center of mass of the rectangular piece, the blue piece. In this case, it would be over here. Its coordinates would be 6, 1, 6 meters over in the x direction, 1 meter in the y direction, and its area would just be that 8 square meters. It's 2 meters by 4 meters. We can use the area again sort of like the mass. The equation for center of mass says the total mass times the distance center mass is equal to m1 times x1 plus m2 plus x2 plus m3 times x3, yada, yada, yada. We can now plug this in. So first of all, I'm just going to work in the x direction. So I'm trying to just work along this axis. The total mass in this case is, I'm just going to do the sum of the two masses. And our 16-foot one is 2 meters over in the x direction. And our 8 square meter one, which again I'm using kind of that, is actually 6 meters over in the x direction. That gives us this. And if you solve that, just real quick, you get 80 on one side, 24 on that side. You'll get the center of mass in the x direction is 3.33 meters. I'm now going to repeat this in the y direction. And so I'm just going to use the exact same masses, but now in the y. Again, the total mass is still the same. This is still 2 meters up as it was before. And the y displacement of this one is just 1. So here's our 2 and a 1 for this one. If we solve this mathematically, we get that. And finally, if we solve for the position of the center mass in the y direction, it's 1.67. Where does it put it? It puts it right about there. So this point right here would be the center of mass of this entire sheet, which again I'm going to write as COM. But that's where it would be. And it would balance. And logically, you can sort of think about it, oh yeah, that should make sense. It should be about that. Hopefully that helps. Good luck.